So the first thing I want to kind of mention here is what a bearing is. And bearings, by convention, are a way of describing a particular direction, but they're always measured from north, which is 0 degrees, rotating clockwise, as you can see here. But it's always by convention from north. So you can see 45, 90, all the way around to a complete circle would be 360. And they're always a 3 digits. So when you have something less than 100 degrees, there's always a 0 in the front. And so for this first question, it's describing most aspects that you see on this diagram. So instead of me reading it all out, there it is. But the first thing I ask for is to find the bearing of C from B. So what does that mean? So if we look at the diagram, here's point B or here's point C. So the bearing from C to B is from the north of B, this direction. It's that angle right there. And so to figure that out, keep in mind, I already know most of this angle, because if I go straight south from point B, I have 180 degrees. So the only question is, what is this last little chunk right here? Well, if we look at our diagram, it says that this angle up here is 100 degrees, and which means this angle from here to here must also be 100 degrees. Therefore, I can quite quickly realize that if each of these angles I've drawn in green are 100 degrees, and this smaller angle here, it states is 79, this must be the difference between 100 and 79, which is 21 degrees. And so I can now answer the first part, because if this little angle right here is 21 degrees, then this bearing from B to C must be 21 plus 180, or 201 degrees. All right. Then I ask for the distance of AC. And distance AC is shown right here as this dashed line. And for this, we could just directly apply the cosine law like we saw in the previous lesson. Because if we look at this triangle here that I'll kind of color in blue, notice we know it's not a right triangle, but we know two sides that are adjacent and the angle in between them. And anytime we have that, we can use the cosine law, where this side here squared will equal this squared plus this squared minus 2, this times the cosine of 79, which sounds more messy than it really is, but let's just do it. And so in this case, I can say that AC all squared will equal, doesn't really matter the order of these, 30 squared plus 23 squared minus 2 times 30 times 23 times the cosine of the angle opposite what we're trying to find, which in this case is 79 degrees. And so that can be done quite quickly on any calculator. This will tell you about 1,165.8, but again, that is not AC, that is AC squared, so we want to square root that, and AC is approximately 34.1 kilometers. All right. The second question is about just making sure we understand angle of elevation, or in this case, angle of depression. And once we understand that, this is a very quick question. So an eagle sits on top of a tree. Let me try to do my best attempt at drawing a tree here. So we got a tree here. Lovely tree. At the edge of the ocean. Oh, here's the ocean. It's watching a boat, because that's what eagles do. They watch boats. And so I'll draw an orange boat here. Ooh. That's a nice looking boat. And can't forget my eagle. There's my eagle. It's that dot. Okay. So it says the eagle sits at the top of a tree watching a fishing boat. The angle of depression is 24 degrees. So what does that mean? Well, from the eagle to the boat, the angle of depression is the angle from the horizontal, because again, the eagle is up here. It's the angle from the horizontal down for angle of depression. So the 24 degrees that's being described is that angle I just sketched out. So 24 degrees is that. If it was angle of elevation, that means the eagle will be looking up at something, and the angle would again still start from the horizontal but go this way, Hopefully this all sounds familiar. And knowing the tree is 47 meters tall, what is the straight line distance from the eagle to the fishing boat? So we're trying to find this angle straight from here to here, the diagonal. Now, as you can see, we've created a right triangle. So that diagonal is a hypotenuse in which I know an angle and a side. Because at 24 degrees, the angle of elevation must also be the 24 degrees from the ground looking up. And so I now have everything I need, and I can see that if I want to find that horizontal distance, that's a hypotenuse, I know the angle, I know the side opposite from 24 degrees. If I look at this 24 degrees, I'm highlighting in green down here, so I can use a tangent ratio. So I can say the tangent of 24 degrees equals opposite over adjacent, or in this case, 47. Sorry, not tangent. What am I doing? Sine, because I'm trying to find the diagonal. The sine of 24 degrees is 47 over the hypotenuse, which we don't know. I'll call that x. And quite quickly, we can see that x must then equal 47 divided by the sine of 24 degrees, which gives us about 116 meters if I round it to the nearest whole value. All right, like I said, a very quick question. Mainly, it's all about, can we visualize what's being described here? Lastly, a fair amount being described right here, but we have, this is meant to be a 3D diagram in which CD or DC is a control tower, so sticking out from the ground, that's a control tower, as well as measurements describing how this relates to two different runways. And again, we have a diagram here, but keep in mind, this is meant to be three-dimensional, so this is sticking up out of the ground here. We want to find the angle of depression from the runway 2 to the control desk. So what does that mean first? Let me do my best to draw it on here. So here's the control desk up here, and here's the start of runway 2. So we want to imagine a straight line connecting these two. And the angle of depression from the control desk means we're looking from the control desk down. So I'll do my best to zoom in on here. So this would be the horizontal looking straight out from the control desk. So we're looking for this angle right here. That's what we're trying to figure out. Keep in mind, I've already drawn another triangle here that I'm kind of sketching in red. So if I look at that triangle, that angle we're trying to figure out is also the same as this angle up here. So I'm going to think about this angle up here to try to figure out. That is our goal. Okay, that's angle B, I'll call it. All right, so how can I figure this out? Well, if I look at that triangle I've kind of sketched in red here, it is a right triangle, but I don't know any of the sides. So really my work is now to find the sides. So if I look at this, for example, I can figure out the height from D to C by looking at this triangle kind of sticking out from the diagram. So maybe to clean this up a bit. Oh no, I got rid of too much. So if I look at this triangle, I'll highlight in green here. I have a right triangle with a base of 340, an angle of elevation of 12 degrees, so I can find now the height of DC, and I can find that using the tangent ratio. So the tangent of 12 degrees, looking at that green triangle, is opposite, which is what we're trying to figure out, divided by adjacent, which is 340. And quite quickly, we can find out that DC must equal approximately 72 point. Now, because I want to use this value later on, I'm going to give myself more than enough detail with the decimals, 72.2692 meters. Okay, so now I need to figure out just one more part of this three-dimensional triangle, and that is CB, that distance from there to there, which much like in the first question of the lesson, I can figure out by using the cosine law, because that side I'm trying to figure out is opposite this 108 degree side here. And I know the two sides adjacent to 108 degrees. So to find CB, I can say that CB squared will equal 340 squared plus 230 squared minus 2 times 340 times 230. Well, that's a weird looking 230. Times the cosine of 108 degrees. And then the usual, all of this here is not CB, it's CB squared. So you calculate that, you square root it, and you should get CB at itself equaling about 465. I'll give myself lots of decimals just to make sure I don't have any rounding error in the end. All right, so now I can find this angle that we were trying to figure out from the start, because now if I look at this sort of three-dimensional diagram, I know the height of it from D to C. I know that's approximately 72 meters. I know the length across the bottom, that's what we just figured out. It's approximately 466 meters. So I can use those now to find that angle B. And again, I'll use the tangent ratio. So to find B, I can say the tangent of B will equal the opposite side, which is, again, 72 and change, divided by the adjacent side, which is what we just figured out. And so that means I'll use the inverse tangent of this ratio, and you should get approximately, I'll round to one decimal place, 8.8 degrees.